meetup, and we do the same thing, like a roundtable talking about technology, and I think that's amazing that you guys do this. The meetup community used to be called the user group community. I don't know if you guys remember that. And that's where people would come in and talk about technology. That's where Apple came out of. So this is the grassroots of the technology movement. It's always been. And so I'm really happy to come and share knowledge with you guys. The major topic of today's talk is really about building search engines and then looking more closely as to why one particular technology will be better than another technology. Who here has actually used Lucene natively? Okay, we got one gentleman, two people. What about SolR or SolR Cloud? All right, we got a few more hands. Okay, and what about ElasticSearch? Yeah, okay, evaluating. More SolR people here than I thought. Actually, if you look at the code commits and usage of ElasticSearch is a little bit more on the it's trending higher than SolR right now. And in terms of other technologies based on Lucene, has anybody used other technologies? Okay. Azure Search. Okay, yeah, we're going to be covering that. Anybody else? Okay. Well, you'd be surprised. There's a lot of stuff that actually runs on Lucene. We just don't really think about it. Okay, great. So just a little bit about what we do as a company. We focus on streamlining, organizing, unifying business information, primarily for the masses of end users in an organization. So this same exact process could be used to make BI reports and dashboards that 5 people in a company use. But we focus on how does the whole organization use this information. And that's why we have to learn search, because if people want to search for something, they don't need to learn SQL. Or they don't need to know how to use Tableau or MicroStrategy. So we really love search technologies because it helps people out. What I want to cover today is the challenge and why search happens to be a good technology to use in that solution. We'll cover a little bit about information retrieval. One of my mentors, Ophir, he wrote the book, Information Retrieval. It's like a bestseller. It's like super esoteric. I'm not going to go that deep, but he basically created the search engine that's used at Twitter, and the real-time search that's used at Twitter. And guess what it uses? It uses Lucene. We'll cover a little bit about Lucene, just so if you don't know what Lucene is, you'll just get the beginner's answer. Not enough to be dangerous, but enough to explain to people what Lucene is. I'll give you a 30,000-foot view of a search engine, how to build one. I'm not going to go into all the components, but just enough to show that it's not as easy as mirroring data from a database into a search index, and why not. And really what I hope for you to see from that particular 30,000-foot view is the index is really just one major part of a bigger picture. And yes, you may end up using one technology over another, but at least from my opinion and experience, you don't want to start with one piece of technology and work your way back. You want to choose a search technology that's after you've done all other homework. I'll compare Lucene, SolR, and Elasticsearch. And then finally, we'll talk about Amazon and Azure, where I'm not going to spoil it, but it's based on Lucene. And what I want is, at the end of this conversation, for you guys to know as much as possible about these technologies. So if you guys have a question, just keep it until the very end, and we can have a roundtable-like discussion, like your format. So I'm going to try to get through this presentation as quickly as possible, and we can always go back to the different slides and cover different topics as necessary. Does that work out for you guys? Okay. Now, is there anything else that I haven't put on my agenda that you guys would like me to cover? Now, I'll write it down so that I don't forget. Anyone? Bueller? Okay. Okay, great. I always do that because some people come to a meetup and they're like, I wanted to learn this, but damn it, that guy had no idea what he was talking about. He didn't talk about X, Y, Z. So, last chance. But you can always ask later. That's okay. So, our challenge. Why did search matter for us? That's where it started. Initially, it was a customer problem. And we had a custom legacy .NET portal product that we took over, Rescue Project. You guys know what that is, right? Somebody maintained it. They stopped maintaining it. They got fired, whatever. So we took over this .NET product, and the search was just horrible. And we had a choice either to use Elasticsearch, use SolR, maybe one of the cloud providers. And at least in our company, we have some learning time. I was like, you know what, I'm going to put in 20 hours of my time to see which one is going to be the best tool for the job. And this client did not have the infrastructure needs to support any sort of, like, they were a pure .NET shop. They didn't want to do anything to do with Java. They didn't want anything to do with a SolR server running on a JVM. They were like, no, I don't want to touch it. So I just basically used the Lucene.NET library and started indexing data. And I'm glad I did that. I wouldn't generally recommend you to start using Lucene.NET or Lucene from the Java side, or or the PyLucene from the Python side. I don't recommend using it for a production grade project. But when you use it, you get to know really how Lucene works, right? You know exactly what the terms are, you know exactly what the fields are, you know what term vectors are. You get to know how this engine works. So when you then get an error from SolR or Elasticsearch, you're like, oh, okay, I understand why I'm getting this error, right? But instead of moving from Lucene when we should have, I said, you know what, I'm going to just make an abstraction layer, and I'm going to keep Lucene as one of the storage systems, and then I'm going to put another for SolR, and I'm going to put another one for Elasticsearch. So today, our framework, we can write simultaneously to all three indexes if needed. Why do we do that? Well, sometimes the index needs to be actually super private, and only 5 people are using it. So we just put the data in Lucene, and it's in a closed system. Or sometimes it needs to have scale that only Elasticsearch provides, or sometimes it needs to have better information retrieval tools that SolR Cloud provides. So off the bat, I'm generally an unbiased person when it comes down to why one or the other, because they have different benefits, pros and cons. Some are easier to grasp than others. But the ultimate challenge was, I've got a ton of information from a ton of different sources, and I need to be able to find it in one place. And this is by the way, this is a classic enterprise search pattern. That's what it is, right? You have different types of unstructured data. You may have some database, let's say, from WordPress. You may have some data coming in as JSON from software as a service, but ultimately it's files and records, okay? But it's not a big data problem, right? This is a small data problem. The data is no more than like 100 gigabytes. And yes, SolR Elasticsearch could have taken care of it, but I'm glad I went through the problem with Lucene, understood its limits, then started leveraging SolR and Elasticsearch side by side and comparing it. Because I like to tinker and I like to have fun with technology. It's one of the benefits of working for a small company that you help start. Nobody really tells you what to do. But just understand that you have to know what your challenge is. If you're just taking structured data and searching it, you don't need to necessarily use Lucene or SolR Cloud. You can just dump it into Elasticsearch. If your data is primarily PDFs and Word documents, I would recommend using SolR. Okay? So you got to start with what your problem is, not what your technology is. Otherwise, you end up spending a lot of the client's money like I did. Or really, it was my own money because I didn't build a client. So information retrieval, I guarantee you guys, you all use information retrieval in some way or form today. There's 2 types of information retrieval generally. One is routing and one is retrieval. You know those suggestions you see on Amazon? Oh, you're about to buy this. You also want to buy this and this and this because 50 other people bought that. Or when you're watching Netflix or binging on some show, it says, oh, you just binged on this 30-season show. I'll give you another 30-season show to waste your time. So that's really document routing. The data keeps coming, but it has analyzed your behavior and put it as a saved query. Okay. Netflix actually uses DataStax Enterprise, which mirrors data onto SolR Cloud. So it's runs on Lucene. Now, Google Earth is a type of document routing. I don't think it runs on Lucene. Highly doubt that. LinkedIn search, pretty sure is Lucene based, but it may not be Elasticsearch or SolR Cloud. A lot of the CMS searches, like Alfresco, will have a SolR connector. Magento will have a SolR connector. WordPress will have SolR Elasticsearch connectors. Many of the CRMs, they don't try to reinvent the wheel when it comes to search technologies. They just partner with one of the existing things out there. Generally, it's Lucene based. Any questions so far about I know I'm talking about the basics, but I wanted to make sure everybody had the same vocabulary. Any questions so far? Okay, great. So what is Lucene? Lucene at the core is just an inverted index. Documents come in, and it's put into one mini index, okay? And it's analyzed, and what it stores, and you can't see it until next to the back of this image, is it remembers where a particular term is and in which document. And depending on your merge factor, it basically starts to merge indexes together, okay? Your quote-unquote document has several fields, and you can say that a field is indexed or not indexed, stored or not stored, or analyzed and not analyzed. And because Lucene is an open source architecture, you can write your own analyzers if you want. You can even write a different storage engine for it if you want. So for example, you could put Lucene on the Azure Blob Engine and scale on the Azure Blob Engine if you really want to just natively use Lucene. But a document goes to the analyzer. What the analyzer does is it breaks it into its lowest common denominators. Okay? It takes a look at a particular field and says this has 100 tokens, meaning it has 100 words. And if there's 5 times like a particular word shows up, it just says this word shows up in this document at these token positions. It just keeps track of where the word is. That's all it does, and that's it. And it saves it into a flat file directory system. And if you watch a Lucene directory, either if you're working on a native format or on an ElasticSearch shard or a SolR search shard, you'll see the directory change over time. You'll see it grow, and every now and then it'll merge back down, and you'll see it grow, and it'll merge back down. If you want to see what's happening in the data, you can download a tool called Luke. Just Google Luke jar. It's a Java program. And you can just open up that directory. You can just point it to that directory and see what the contents are. You can even run sample Lucene queries to see what's there. It's not something your end users will use. It's like an admin tool. And I've actually used Luke on like a SolR shard because some data was getting corrupted. So I just like pointed it to the index directory and I was able to open it up. I'm not a big fan of this storage and file system, but it works fine. It works pretty well. In fact, all databases eventually have the data in a file system, and they store some data in memory. So any questions about Lucene as an inverted index? Okay, go ahead.
Yeah, you said it tracks different terms. Does it track like every term?
Every term except for, let's say, you can configure to use stop words. So to not use stop words, so you can have like a, the, or. It won't track that. Okay? Because why would you store every place there's an or an and? But yeah, every word.
Okay.
Yeah. And if you want, the position, where it is in the document. So you can highlight it.
Does that not take like a ton of memory?
Hard drive space is really cheap. Memory is very cheap. And that is the use case. You want to find a needle in a haystack.
And fast.
And fast. Okay, does that answer your question?
Yeah.
Okay. Cool.
So you're saying you have all these fields, right? So
yeah.
Are you defining your data structure before and then you're sort of processing the document, or sort of dynamically sort of getting all the all the values?
It depends. If you're using Lucene natively, yeah, you create a document. You say add field, add field, add field. Okay.
And then you define sort of the position within the document where.
Oh, well, you say add field, indexed equal to true, analyzed equal to false, stored equal to false. And I'll get into that in a second. Why do you want to store a value versus not? So you can have a small index that doesn't store the data itself, but just tracks the position. It'll be a pretty small index because it just has the word, the document, and where it is in the document. And that's pretty tiny data versus the actual full text. Or certain systems, that I'll talk about, you can do basically an unmanaged schema. So both SolR and ElasticSearch both have that. Azure Search, you kind of have to define it, and if you need to redefine it, you have to reindex. That's unfortunate, because when I get into it, you'll see like it should be able to do it, and they may be doing that eventually. But the answer is yes and no. It really depends. When we use it, we assume that we are managing the index schema. Okay, because we write to Lucene, SolR Cloud, and ElasticSearch, and working on the cloud search providers and the Azure search provider, and maybe even Algolia search provider. So We don't want to we want to use the lowest common denominator. Okay? Does that answer your question?
Yeah.
Okay, great. So, any other questions about the inverted index?
So you were saying earlier that if you have a lot of PDF or Word documents, you might want to use Lucene or
Sure, I'll clarify that.
okay.
If you have PDFs, SolR has a lot of data import handlers built for XML and PDF, especially using the Apache Tika project, which is actually something that came out of the defense world, but it can index text inside images and text inside videos. Okay, so there's like 100 different formats it can index. So what SolR does is when you use that data import handler, it says, oh, this is a PDF, I'm going to use this particular data import handler. And it extracts the content and metadata. Okay?
That answers my question. Like,
Yeah.
how does it figure out like what binary format?
Yeah. You can use on the command line on curl, right? Grab the data, export the content, pipe it into into ElasticSearch. So you can do that too. Yeah, go ahead.
Yeah, with Tika, what we did also is it has nested documents. If you have a document and attachment to it, Tika is very good in doing that, extracting both the nested documents. So we can also do the right tree and things when you want to index them. You can really go into the deep into the thing, say that this term occurs.
Yeah. So Tika is a separate Apache project. Okay. We use Tika outside of the indexing process completely. So we assume that we're going to give the text into the index. Okay. At another really massive search project at the patent office, we're using SolR Cloud and Cassandra. Before we put the data into Cassandra, we clean it and we get the data from Tika. So by the time it goes into the system of record, it's already text. It's a little bit easier to deal with. Okay, does that answer your question? Okay, great. Any other questions?
So most of the time, you're gonna capture the text as your work, I mean,
Yeah, so when you put this document right here, think of it as like a NoSQL database, right? You create a document, you add a field, you say it's an integer. So it'll analyze it as an integer, or they have geospatial fields, right? Or it's a string, or it's text, full text. So when you create your document, you specify what you're putting in there. But generally, it's human readable. It's not binary data. I mean, right? It's information text retrieval. I guess when you use, let's say the Tika parser for an image, when it reads the image using OCR, it just uses OCR to get the text, and it stores the text inside the field. Okay. Any questions? All right, cool. Next. So Lucene is everywhere. Okay, it's like Skynet. You really don't know where it is, but it's everywhere. So quick, fast. RavenDB is a NoSQL database built for .NET that supports sharding and scalability. What it uses Lucene for is searching that NoSQL database. In fact, the guy who's one of the major contributors to that project, he is a major contributor to the Lucene.NET library. Okay. Apache NiFi came out of the NSA project. It's like Yahoo Pipes / ESB, like an enterprise service bus. The team got acquired by Hortonworks. It's called Hortonworks Dataflow. It uses Lucene for its underlying queuing engine. So as the data is moving through the different processes, it just serializes the data into Lucene, picks it up very, very fast. ElasticSearch, obviously, started around 5-6 years ago. Cloud first. Their goal was to be elastic. Kibana works really well with Elastic. It's a GUI front end that if you point it to Elastic and it has time series information, you can do really simple visualizations. Nice graphs, yeah. So if you have data and you want to see how it changes, dump it into ElasticSearch using Logstash and visualize it with Kibana. And that's not just server data, not just server logs. Like you want to see the activity of your sales team, like how many calls they're making, get that data out of Salesforce, dump it as a log entry into ElasticSearch, give out, and it will show whoever wants to know if your people are slacking off or not. But that's not the only thing. There's another one called, so that stack is called ELK. Okay, Elasticsearch log stack Kibana. In the SolR world, there's something similar called Silk, basically SolR log stash, and it's not really Kibana, but they call it Banana. Both of them are actually forked enough where they're distinct. They're different enough where Banana can visualize more than just time series data. Obviously, Lucene itself, the core, SolR, a big part of Lucene. Actually, Lucene and SolR are part of the same Apache project. Okay, so when Lucene comes out with a new version, SolR has a new version, and vice versa. Cloud searches work. It runs on SolR Cloud. It used to be on something else, but they moved over. Azure Search it runs on ElasticSearch. And actually, Microsoft has been using Lucene for a long time, for Hotmail and for Bing. That's been using it for a long time. Apache Jackrabbit is a Java content repository. Cloudera Search. Cloudera is a big data Hadoop stack distribution. The inventor of Lucene does cutting, and the inventor of Hadoop works at Cloudera. Hortonworks also uses SolR. MapR also uses SolR. Why do they use SolR and not ElasticSearch? A lot of politics, but essentially, Apache SolR Lucene is 100% open source, true open source. Elastic, only the founders of ElasticSearch, or not founders, the employees of ElasticSearch can commit code to Elastic. They're open to ideas, but yeah. So this is community first. And there's so many tools available in the Hadoop system that work with SolR. We'll get into that a little bit later. Titan is a graph database where graph databases are different from document stores or other NoSQL databases, but it has a provider to index to SolR and I think also to Elasticsearch. You can put your stuff in a graph and it'll be indexed in either one. Any questions about what you see up here? No? Oh, and I didn't put, because I just didn't have enough white space, I guess. Tons and tons of consumer sites. As I mentioned, Lucene uses Twitter uses Lucene on the cloud, but not necessarily SolR Cloud or Elasticsearch. Okay. Comcast, they use, when you look for like the TV guide, you want to see what's happening, you want to search for a movie. That is a massive one-node SolR Cloud index. And they actually started off using Lucene, and the guys were like, they're just doing housekeeping. So they just went to SolR Cloud. Netflix is also one massive index where the data is basically in memory. Who next? Maybe you guys, right? Your project, your consumer-facing project, or some enterprise technology. You can use it. The question is, why do you want to use it? You don't have to use something when you don't need it, right? Any questions here? Yeah, go ahead.
Basic question. What's the difference?
Okay, so that's in the next slide.
Oh,
okay. All right. Okay, so this is the 30, not in the next slide, but it'll be in the next slide. Sorry. 30,000-foot view for search index. This is our approach. A lot of people say it's just ingestion, indexing, retrieval. But we like to break it up into kind of component parts. The process aggregation for us is to identify the source data and understand what it is. Okay? So is it a directory full of PDFs? Or is it a directory full of text files? Or is it a structured data set? Or is it a directory full of JSON files? Or is it CSV? So, but aggregation can be different. If it's a database, we may have CLI access to it. We may have API access to it. If it's a web service like on Salesforce, we have different access to it. Let's say WordPress has both. We could probably get both MySQL access and the new WP API access. Doesn't suck that bad, right? So there's different ways to get data. So we get the data as natively as we possibly can, because if you do it in that architecture, if one of these processes fail, you can store it somewhere. You can then restart that process of collection. Collection for us is take all the data and make it into a standard format. All right? Why do that? You have 5 sources with an average of 15 objects, and you don't do that. All right? You're going to have 85 different objects. And technically, you may want to have that in your search capabilities, but at least our use cases, that's not what some people want. Our use case, we actually learned from, our next process of extraction, we use both a file-based staging area and sometimes in memory. This is an idea that we got from Stack Driver. They have a really good video for AWS Cassandra best practices. And they said, we get the data and we dump it into S3. And then we save it, because S3 storage is very, very cheap, right? So if anything happens, you can always replay. I was like, that's brilliant. Just save the data and index it. If you have to rebuild the index, you can always just go back to a certain date or certain span of dates and get the data again. Don't worry about the technology. These are more patterns. We have an idea of a base source and a base stage. A base source is like a data lake. You guys know what a data lake is? What is a data lake?
Huge amount of data in one location.
Huge amount of data in one location that you can access.
Yes.
Right? That you can access. And so what we do with the data lake is we then create cleaner objects that are related to each other. Okay? And that requires sometimes a metatable. Okay? How's that done? It's a really hard question to answer because some people they have a map. This customer ID in Salesforce is this customer ID in HubSpot. Or they want to magically, using machine learning, figure it out. I'm not going to get into that. But the goal of having a base stage is clean objects, maybe in a star schema, that is ready for dumping into a data warehouse or dumping into a operational database. But you don't even need this. You can just clean your data here using Spark or whatever processes you want. You don't have to use Spark, MapReduce if you want, and then dump it into search. If you don't do this, basically, it's your search index is only as good as your data as you process it. If your junk comes in and you put it straight into search, it's going to be junk search results. Okay. You can do a lot of things at this stage. You could combine several records from several systems together as one massive object and index it. And why have a database and a search index? Because search indexes are not databases, and databases are not search indexes. You can do quick, fast searches, but then you want to view the record, get it from the database. Why do you want to put that? Yeah, that's another search query on a very kind of like complicated search index, right? It's storing this stuff in memory. Why bother it with a single document request? And that's a debate you can have with somebody at the happy hour. That's my best practice. If you're going to do search indexes, have a system of record that you can point to that you can even put this in like Redis cache or some other sort of memcache if you want to get the data very, very quickly. But don't burn the index to store the data. There's a reason to store the data in the index. Do you guys know what that is? No, that would make it slower. Why would you store all the data in the index and not even have this? Or you could have this, but also store the data in the index. Why would you have that? You don't have the source. No, we just assume that our source of truth is going to be here. We can always go back to it.
If you're just crawling a web, all you need to store the data you have.
Right.
And probably store that in index. And it will be one. If you want a source document, just millions of documents, you want a source, you can move that source in the database. Then just point in the index, just have the schema of your index there, and then if that click a term and you get the response back from what you're searching, it will point to the actual source code, which is actually a key to your database.
Right.
And that's sometimes for highlighting also.
Highlighting. That's what I was going to say. What you said is another reason to put it in a database.
Yeah. Or
if you don't have the resources, you just keep it in the index. But for highlighting, people say, well, why don't we just retrieve the data from the database and use JavaScript to highlight it? Yes, for like 1 or 2 words, that works. But Elasticsearch and SolR are smarter than that. You have these query parsers that you can do like proximity-based queries, like this word within 5 of these words, right? To do that in JavaScript, you basically have to re-index the document in JavaScript, right? So that's why you would store it in the index. And there's always scale problems there. I have a theory of how Google does it really, really fast. And it has something to do with caching. But this is a 30,000-foot view. Just acknowledge that search is an endpoint of multiple things happening before. Okay, so could you not do this? Yes. Could you just take and put it in here? Yes. Maybe that's a proof of concept, right? You just get the data, put it in there. Is this thing changeable? Can you put this in Lucene? Yeah. You can put this in ElasticSearch. You can put this in SolR. You can use Microsoft SQL Server. You can put this on Aurora DB on Amazon or Postgres or Greenplum. It doesn't really matter where you put the data. Building a search engine is a process. It's not, I'm going to use SolR Cloud to make a search engine, right? So I just hope you guys walk away with that understanding that these technologies are just decisions that you make after you know what you're doing with your data. Okay? All right. Now the good stuff. Why would you choose one or the other? So the blue is the pros and the black is the cons. And I didn't want to have like a 3 by 36 grid with check marks and stuff because you guys can find that on the internet, right? There's several websites that you can find that. Here's the reason why I look at these tools and why I use one or the other. So Lucene it's a library. There's libraries for every major programming language. It works in the file system, so you can put it on Hadoop, HDFS. You can put it on Azure Blob, and it'll work the same because they've abstracted how it gets spread out, right? I don't know why this says formata, but that's it's a format. It's a file format. That's all it is. So if you come up with a new programming language because you have the time, like Google does, to make Go, right? You can make your own, library that writes that format, and you can read from that format. It's open standard. It's fast because when you load it, it stores it in memory. That's why it's fast. But you don't want to put more than maybe a terabyte because you don't have the memory in your machine anyways. And to scale Lucene, you have to use something like Azure Blob Storage. Or you have to use one of these other ways of dealing with it. And that's the sharding and replication factors. But you can get by with this. If you want to put search in your mobile app, in your iOS app, you can embed it in there. Okay. One of the companies, Algolia actually, when they were first starting, they wanted to make an embeddable search library, and they decided to they don't use Lucene, but they ended up making a REST service for search. But they were playing around with Lucene and embedding it as an SDK. So you can index anywhere. I think people are maybe familiar with SQL Anywhere by Sybase, right? You can index anything anywhere in your PHP code if you want to. I don't know why you would. But you really need to know Lucene to use Lucene. If you want to go that route and become an expert on search stuff, Lucene, like if you take a master's level course in computer science, information retrieval, quote unquote, the examples are all using Lucene for ingestion and indexing and retrieval. There's no interface except the code that you write. If you make all your interfaces. There's no server. Your code is the server. Okay? Nobody's supporting it as a daemon on port 8983. Okay? There's a lot of housekeeping, basically. You want to make a new collection, you got to make a new collection. You want to delete a field, you got to delete a field. Okay? Any questions about Lucene as a library? Why it's good or why it isn't good? So we use it actually for one of the storage providers for our execution engine. So we can save data in memory, MySQL, RabbitMQ, or Lucene. Because if you store it in Lucene, it's embedded, and it's really fast, right? And if you store the data on a shared file system, it's smart enough to know who's reading and writing from the different, let's say, worker processes, where it's generally concurrent aware, okay? Concurrency aware. SolR, it's a server product, meaning you install it, you can deploy it as of 4.10, you could deploy it as part of Tomcat or as JBoss if you wanted to. But now it comes embedded with a Jetty server. I don't really care, honestly. Admin REST interface. So it's an admin interface. It's web-based, where you can look at the collection, you can look at the segment health, you can see terms and how many times they occur. And it's a pretty graph. It's not like amazingly cool. It is configurable, because you really have to know what you're doing. It is scalable, which you have to know what you're doing. It's great at text, unstructured text. I think it has way more. It has like 16 different query parsers. It's really good, which is everything inside Lucene. Everything Lucene ships with SolR has. Okay, it is truly open. It's been around for more than 10 years, 12 years, I think now. Generally good ecosystem. I think it's too customizable. If you don't know what you're doing, you're going to break it. You need to know schemas. Like if you want to start off with one of the examples, it will have a schema for you. And start with another example. It has a unmanaged schema. And you need Zookeeper if you want to scale it. Why do I use SolR? Once you configure your default collection system and how once you have a strategy, like we have a canonical message format that's, people use in enterprise service buses. We have the same type of canonical message format for search. And we're always generally going to use one format for metadata and one format for the actual data. So once you're okay with your practice, you can just stand up SolR and work with it, right? ElasticSearch, on the other hand, has a lot of those things: server, configurable, scalable, generally good ecosystem. I think I overheard somebody talking. It's a lot easier to get started with ElasticSearch. If you download it and you run the thing, it's running. In your code, you can do a curl command and start dumping data into it. It'll start working. Okay. People use it for analysis. In fact, Amazon has an ElasticSearch cloud product that's a group under analytics. Okay. Really good for logs. Just dump massive amounts of log data, group it, filter it, look at the spikes, count, group by, etc. And the reason it's really great to get started with on the cloud is because it was built on the cloud. It was built with the idea that the indexes needed to be sharded and replicated and grow from there. I don't think it really has a great interface unless you install Kibana. So you have to kind of install Kibana to look into stuff. And only has a REST interface in terms of like the actual server. There are libraries for ElasticSearch as there are libraries for SolR, but SolR has something called SolRJ. And SolRJ is Zookeeper aware. So when you use SolRJ, you point to all of your Zookeeper members, your Zookeeper ensemble. And it will go talk to the Zookeeper ensemble and say, hey, where should I read or write from? Okay? So that's where you have to do a lot of inputs and outputs and do near real-time stuff. It wasn't there earlier. Okay, ElasticSearch really had that to start off with. But SolR has SolRJ. That's the one thing that it has in the cloud world, which ElasticSearch really doesn't have. Any questions about high-level Lucene, SolR, ElasticSearch? Any questions?
One of the things between Lucene and SolR, what about faceted search? I heard that SolR is covered.
Yeah, both of them have faceted search. Okay. So just to be clear, what is a facet? So let's say you have a field, date published. Okay. And you're storing in there, I forget date published, that's a really complicated one. Let's say product color, product price. And you want to do a facet to say, show me how many products are red, how many products are blue, how many products are green. In SolR, you could say, the facet query FQ is this field. Or you can even make it a query. And it will take the results and it'll group them. And it'll show you how many of them are there. ElasticSearch also has that. Okay. In fact, I heard that ElasticSearch has even deeper faceting to have like decision trees. But going back to SolR has like almost like pivot tables. So you could do a facet and then pivot your search on that facet.
To speed up compound searches.
Pardon me?
To speed up compound searches.
Yeah.
Sort of.
Because when you search SolR, it stores that search inside the document IDs. So then if you're doing another filter on that, it just needs to look at those particular document IDs. Okay. Yeah, go ahead.
Are we only talking about static facets or dynamically
You can do dynamic facets in
Yeah,
those.
that's all.
Yeah, so you can say, show me the things, and Arthur's knows this. Show me the things that last, and also Quinn. Show me the things that last 30 days, 60 days, and 90 days, right? That's the dynamic facet. But they both have it. I just think that, like, there's this tool on GitHub called SolR Ajax, an Angular product. You can download it, point it to your SolR collection, and magically it will detect, or you have to give it a little bit of configuration of what the facet fields are, and you will have an interface that looks like this. You can't really see it, but the facets will show up, and it's auto-suggest here, and start to show the data there. So that's why I like SolR a lot. By the way, faceting has its own different ballgame. If you don't optimize your facet queries, the retrieval speeds are horrendous, okay? Because it's looking at the whole collection.
And you can do facet search on Lucene too?
Yes, you can, but you're building the facets yourself from the document list. So there's a tool called Bobo Browse. Initially, it was in Java, and now there's a .NET version 2. You can say, give me the facets, and it'll give you the facets, okay? Just Google Bobo Browse. It's actually, if you want to learn Lucene, go to an open source project that's using it. So Bobo Browse is excellent. It has like a car database. It dumps it into a Lucene index automatically from an XML file, and it has a web-based interface. It's a .NET project, and you can run facets. Yeah, that's pretty cool. We were thinking about, before we decided to use SolR and Elasticsearch, like, and the other cloud providers, were like, oh, maybe we can take Bobo Browse and really make a production quality. No, waste of time. Any other questions about this slide? Yeah, go ahead.
Does it do, I guess, fuzzy matches for Azure Search?
It has fuzzy matching. It depends on which query parser you're using, okay? Because there's so many different query parsers you can use, okay? And it also depends on how you analyzed it. If you didn't analyze it with, let's say, it's called flop words, for example, right? Not fuzzy matching, let's just say flop words. Then you couldn't look for like director, directory, direction, right? So what it does with slop words, you have to say allow slop words in this, and it actually indexes all of those words pointing to that particular token. Okay? You had a question back there. It's your code. It's only as fast as you are. So you have to choose a file system provider. You can say file system directory provider, or you can say file system Azure Blob provider, or you can say HDFS provider, right? And it'll depend. There's even so this became part of the DataStax project. It was called Lucandra. It was storing the data on a Cassandra database. Okay, so it just depends. It's extendable, right? So if you want to, you can change it. You can make your own that sits on top of pure SSD drives, which is basically cheap storage, right? Or cheap memory, excuse me. So it'll be fast. Yeah. So as I said, Lucene, there's a lot of housekeeping, right? You have to do that. More than the LRU caches in Java, you have to do that. If you want a caching, just use SolR and tweak the caching mechanisms. It has LRU cache built in. Like if you do a star.star or star:**, you get all the documents, and you say FL equal to false, basically, don't give me any fields. It'll just give you the num found in the index, right? Then the next time you do that and you say FL equal to star, it will be faster because it has just kept that query in memory, okay? Or anytime you save a filter query with facets, it's in memory. It stores that filter query as a list of doc IDs. So it doesn't have to go iterate through the whole index. It just runs that algorithm on that small set of data. Okay, so you could prime your index, get it up, put the data in there, run a curl command that hits the REST interface to run 50,000 queries that are primed already. Right? Cool. Any other questions on this slide?
I think we should talk about the actual best practices of ingesting this.
I can go back to that. That was on the 30,000-foot view, so we'll do that Q&A for that.
Yeah, that's all.
Okay, great. Any other questions about comparing these tools? Okay. All right. So then the question is, why would you not use these open source tools, and why would you use one of the cloud providers? Azure uses ElasticSearch inside, but doesn't expose an ElasticSearch API. Amazon uses a SolR cloud system underneath, but it doesn't use the SolR API. Okay, so it's like using another indexing system. They expose two parsers, simple parser and the Lucene parser. I think they have like a fuzzy, and they have Lucene, Dismax, and like two other. I haven't memorized them. I want to say you can do dynamic fields here. I thought I read it. You can't do dynamic fields in Azure. I know that for sure. Neither of them do nested objects. And you're charged for data read and writes because it's a cloud product. This is only a few years old. That one's been around. They just kind of like changed the engine under the hood. Apple uses SolR Cloud. Like a lot of stuff that you use. Amazon, on the other hand, why would I use them? Because so many of our clients, we manage virtual private clouds for them. It's just another click to add a search index there, right? We already have systems in place there. And ideally, actually, if I were to give this talk to you 6 months from now, I would say use Docker. And you could use Docker on Azure, or you could use it on Amazon, okay? And why would you use Azure Search versus Amazon Search? You wouldn't. You could technically run your index on Docker and scale that on S3 or another dynamic drive or Azure Blob Storage. I haven't tested it out, but I think I'm drinking the Docker Kool-Aid. It's pretty cool. In terms of where would you choose one or the other today? Who uses Amazon Web Services for like majority of their infrastructure here? There's only 2 people, 3 people, really? 4? What about Azure? 5 people. Okay, really? Where do you guys host your stuff? On-premise? Really?
Because we work in federal space. We have
I heard. Okay, well, at PTO we use AWS for the lab environment. We don't use it for the actual production or PPT or whatever. So in that case, you have to make a decision on the other slide. Okay. So this is really not too relevant for you guys. All right. So that's.
Quick question.
Yeah. Go ahead.
AWS also has a hosted ElasticSearch.
It does. Yes.
Any comments on that? Like,
Yeah.
how is it or better this?
So if I were to choose ElasticSearch or Cloud Search, okay, why would I choose ElasticSearch? Because it's a native REST implementation the same as Elasticsearch. So if I'm programming something that's talking to Elasticsearch API, and if I instantiate Elasticsearch Cloud, you can just write to it. There's no changes required. It's good. But they sell it under the analytics group of products. Yeah. And by the way, Elasticsearch has a lot of cool stuff around it. They've compared Elasticsearch with MongoDB, okay, to put JSON and retrieve JSON. You don't have to write some stupid JavaScript MapReduce job to do a join, right? Kind of stupid. Or Elasticsearch has SQL-like interfaces using crate.io, or Redash is a dashboard project. Both of these are open source. SolR 6 is going to have SQL. Meaning you can select data from your collections with a SQL command, and they'll have a JDBC/ODBC provider. So they all have the same stuff.
I see a lot of people saying, like, as for the use cases, so MongoDB is slightly replaced by this
Elasticsearch
in certain use cases.
Yep. MongoDB has some cool tools, but yeah. All right. There was a question about ingestion, and then I'll end at exactly at 8. Is that okay with you guys? Okay. All right. So ingestion best practices. All right. So for us, ingestion is a multi-step process. We're all taught from the textbooks, just get the data and dump it. All right. But that's like a hello world program. All your code isn't going to be hello world programs. Okay. If you use SolR, it has data import handlers. And at least what I know from Comcast, I didn't work there, but I know people that work there. They have data import handlers that read the data. They don't make an external program because it's in their massive, huge JVM. And when the data is detected, it just goes in really quickly. For Elasticsearch, there's rivers, okay? But you have to make sure that the data is good enough to go into your index. So the preparation process should be clean, okay? And that process is if your end goal is only to produce an index. In our use cases, we have to produce an index that is then generally pointing to a collection of objects in what we're creating as a central system of record across various SaaS systems. So we need to prepare the data properly before we ingest it into the index, okay? So this architecture, you can do as one console application. You can do it as a bunch of PowerShell or Bash scripts, okay? You could do it as a bunch of componentized Docker containers, okay? So I think the best practice for ingestion is break up your work into small components and just understand what's happening at where, and then log everything, right? So if you're aggregating something, say this aggregate has 293 objects. Then it goes to collection. It'll say 293 of 293 objects collected. Then it'll go to extraction. 293 of 293 objects extracted. So if you dump it into Elasticsearch, right, or you just dump it into a log file and have Logstash, record it, you can always figure out where the data went wrong. Okay. Another best practice that we're learning to implement now is it doesn't have to be a queue engine in the proper sense, but have a status table for each of your unique system objects. So when you discover a system object, register it and say, aggregated equal to true, collected equal to true. And you can always have like a progress bar as to where the stuff is. And you can dump that anywhere,
So our challenge was to, we have millions of documents. So we want to move away from all the Lotus nodes documents. They wanted to be able to search. So they were sunsetting the project called Lotus nodes. So we are supposed to move all the millions of documents into a data lake and then be able to index it, search it. So our mandate was to create 50,000 or 200,000 documents per day. So we couldn't do document by document that would create an index that will be merged like every 5 minutes, right? That's
right.
not optimal. So our plan was, sorry I'm taking your time, but the whole plan was to have 1,000 documents at a time.
Right.
Workflow. But one problem is that if one document fails,
Right.
the whole 1,000 has to be
Re-ingested.
Workflow re-ingested.
Right.
So that's the kind of challenges.
Same challenge we have with the PTO.
Okay.
So the way we do it is we take the source files, we clean the data, we put it into Cassandra. Once it's in Cassandra, it should be checked with, you can check it with a Spark job, okay? And then we use Spark. So initially we used the SolR Spark context, okay? Where you can say, you know, select from the Cassandra table, filter by this, insert into SolR, right? And, you know, 24 nodes, it takes its sweet time. But when it's 120 million records, you kind of have to break it up. So what we did was we broke it into, for the different collections, there's like 9 or 10 different collections of patents, like Japanese patent organization, European patent organization, whatever. Each of them has slightly different fields. So we had different collections in Cassandra because when you do a Spark job on one table, it's distributed across all the Cassandra nodes. And if you do it across one table, it's just really, really slow. So we partitioned the data inside Cassandra to make it manageable. So our mandate is 120 million records in 24 hours. We were close to that, but then we had to make a change in the schema. Again, that's a different discussion where we have to do more analysis on the data. And it's slower, but the retrieval quality will be better. So I don't know if I've drank the Spark Kool-Aid, but I've definitely drank the Scala code. I love Scala. Like I've been using .NET for 16 years, Java for 20 years. Scala is pretty sick. So when you're using Scala on Spark and this magic happens on like terabytes of data, you know, it makes you have goosebumps. You're like, whoa, that's so much power. Especially when you say, without compiling code, select this, filter this, MapReduce, insert into. And, you know, it does the workers and it ingests the data into SolR. So, any other questions? Yeah, Arthur.
So when you're, so if you're using, if it's document ingestion or it's log files, it's pretty clear you want to use something like, so most applications, many applications are basic business, CRUD, relational database applications. And then they get to the point where they say, either we want to search for something or we want to show some fancy charts.
Yeah.
What's your opinion
Fancy
on
charts equal to ElasticSearch.
or D3GS?
Yeah,
so,
well, plus
D3GS.
Yeah, exactly.
So what's the tipping point where you say, well, we have our Postgres, we have some other relational database,
right?
And now we're going to bring in ElasticSearch or SolR, because you could feasibly, you could go either way, right? You could do a search against your relational database.
Yep.
Relational database does a caching, there's a lot of performance in there. And you could say for charting, you could also pull out the right data and you could play a chart.
Right.
So what's the tipping point where you bring in those?
That's a really good question. As I said, I mean, I kind of brushed it off, but that's really where, if there's a lot of grouping and filtering and visualization, and I want to do a count by state and visualize that on a map, I would do that in Elasticsearch. And with the other tooling like Redash or Presto, not Presto, Redash and Crate.io is another system. I can do SQL-like queries. So I could point a regular old BI tool that supports SQL to Elasticsearch, and it'll be pretty fast. So it does both what you wanted. It gives it.
Does it have transactions? Are there transactions supported in SolR and Elastic?
That's where I would never use SolR or Elasticsearch as a transactional system. It's not a database. It's not ACID compliant. You know, when they're talking about consistency, accessibility, and persistence, like the CAP theorem, that basically means that, sorry, dude, use a real database. Yeah.
It's most of the time when your life doesn't depend on it.
Yeah. Yeah. I mean, that's why a lot of the log, there's so many different outsourced log analysis providers. So many, right? They all use Elasticsearch or something like it. Why? Because it's not mission critical that the log entry came in, and I don't know what Splunk uses, but you know, it's not mission critical that a log file came in from a server and went into this thing and was shown at the moment it showed up. It's not that important. But if you use something like, the Cassandra will be a slightly better use case for that. Because if you set the quorum to say all, the moment it hits the database, all of the nodes have it, and those nodes could be on 20 different regions across the world. Every node will be aware that something happened, right? And that could start a Spark job or whatever. So in that case, I don't think SolR is, or Elasticsearch is, an operational database. Just like MongoDB isn't an operational database. There's so many times where you dump data and you lose it. But it's a great search interface, like, you know.
And search and analytics, right?
Especially Elasticsearch for analytics.
Right.
Yeah. And it's to be determined whether the SolR 6's select system, if you start doing group bys, whether it'll perform the same speed. So we'll see when that comes out. Okay, one last question, and then we should wrap it up.
This is not a question. This is I want your opinion on this. So it is when we write into SolR or Lucene, we leveraged distributed file systems on resiliency factor for application.
Mm-hmm.
So in your opinion, is that good to use HDFS kind of file system or Linux file system?
Sure. So
performance-wise,
in my experience, SolR on HDFS is really fast, okay? Because SolR knows where the term is in the document, and it knows where the document is in one of the cloud members. When you start to do things like proximity searches, where it's like using a span near, or now there's something called span within and span contains, where basically you say, here's my query, find another query inside this query, right? It has to look for that query in all of the documents. And that's where it croaks. It just chokes and dies, okay? We're doing proof of concept on HDFS with 120 million documents. And the Boolean queries, 0.1, 0.01 seconds, like that, like so fast, right? We're like, great. Then you start doing, so there's one proximity-based query that comes with Lucene and SolR, but it does not do everything that we need. So we have to make a custom one. So it's like, search for this word within this sentence, or search for this word within 3 words of this other word, or search for this word within 3 paragraphs of this other word. That's the kind of stuff that patent officers ask, right? So that query would come back in 120 seconds because it has to look for that, because we put a marker at the end of every sentence, and we put a marker at the end of every paragraph, okay? And now it's even, I mean, this is a whole different discussion, but there is a place for each file system. Certain things just doesn't work, okay?
So what you did, that's what we did, but it was more optimized for retrieval.
Yeah.
The ingesting was not that, you know.
Yeah. Yeah.
Once you have the 120 million files you want to do it, that's fine.
Right.
But what happens is you're not done there, right? You're continuously doing it on a daily basis.
Yep.
What happens is it has to optimize its index itself.
Yeah.
So it will tear down the
Yeah. Especially on HDFS, it's not so great.
Go by retrieval optimization or your ingesting optimization. Depends on your workflow.
Yeah. Yeah, that's another discussion we can have. You had a question and you haven't spoken much.
Well, I was wondering, you know, because when I looked at this a long time ago, basically the search engine part, pretty much you can well, first you can write that part, but the magic of all search engines is the quality of the search when you give a term.
Right.
And it wasn't really clear, at least when I was doing it, whether it was like not like drilling holes in your head to get SolR to have tweakable,
right,
tweakable things off of the index that it had.
Right.
And it wasn't clear on your slides where that part fits in.
Right. So there are boosts in SolR where you can say boost this field higher than this other field, right? And you can do that at index time and at query time. Okay. Or you could write your own custom analyzer that at index time.
Well, yeah, but if you didn't want to do it at index time, just basically if you change your boosting thing, then you have to re-index everything to get the new thing.
But you can do it at query time. You can do the boost at query time too.
Okay.
It's slower, but it's fine. because it doesn't have the weights already in there, right? It's calculating the weights on the fly. Okay. I think I should be quiet and let Sarah close us out. Okay, my information is here. I'm going to put this on SlideShare and send this link to Sarah. I give these talks. If anybody wants me to come and talk at their company, free of charge. I like speaking and sharing knowledge. And our company does this stuff. I'll sit down. Thank you.